Okay, here's a question that we didn't look at a whole lot in class. It's where you're dividing a polynomial, like this one, by a binomial. So a polynomial by a binomial, where specifically the binomial has a number out front of the x. Now, we could, I guess, try and do synthetic division, where I have a 6, a -1, I don't have an x term, so I'd have a 0, and then my constant term would be a 10, do my fancy little L thing. But then, what number do I put out front there? Like, I can't really put a -4, because there's a 3 there. So, it turns out there is something that we could do there, but let's just maybe, I'll show you how you can do it long division. On a test, I'm not going to ask you how to do long division, but I'll show you long division, and then you can try it from there. So long division, you write the divisor over here, and you write your quotient here like normal. So you'd have 6x cubed minus x squared plus 0x minus 10. So you'd have to include that term so you have every descending degree in the polynomial. Then you take the first term here, don't worry about the 4 for now, and divide it into the first term here. So 3x into 6x squared goes 2x squared times, I think I said squared, it was cubed, 6x cubed. Then I multiply this by this, and of course I'll get 6x cubed, but then I'll also get plus 8x squared. Okay, now we'll subtract. Careful with this subtract. So 6 to take away 6 is nothing. Minus 1 minus 8 would be a minus 9x squared. Then bring down the next term. So plus 0x. And then how many times does 3x go into negative 9x squared? It'd be a negative 3x times. So negative 3x times 3x would be negative 9x squared. Negative 3x times 4 would be negative 12x. Subtract again. Notice I like to put the subtract, put a circle around it just to indicate that's my operation. Minus 9 minus a negative 9x squared cancels. 0 minus a negative 12 would be a positive 12x. Then I'll bring down my last constant term. And lastly, divide 3x into 12x. That would go 4 times. 4 times 3x is 12x. And 4 times 4 is 16. So positive 16. So when I subtract, 12 minus 12 is nothing. Minus 10 minus 16 would be minus 26. So my remainder is minus 26. Now it turns out that if you wanted to, you could do this with synthetic division too. In the other ones, we had, if say I had a question where I had x plus 4, and I'm doing my synthetic division, I would change that to a minus 4, right? And then I'd multiply, add, multiply, add, multiply, add. But if I have a number up front there, it causes a little bit of grief. If I were to have x plus 4, one way I could get the minus 4 is make this equal to 0 and then solve for x. I'd subtract 4 from each side, and of course I'd get x equals minus 4. I can use a similar idea with this one. So if I have 3x plus 4 equals 0, take the 4 to the other side, becomes negative, and I have a 3x here, then divide each side by 3. So actually the number I could put out front here would be negative 4/3. And you're asking yourself, how in the world are you going to do that? Turns out you can. 6 times negative 4/3 would be negative 8, I think. Minus 1, and now we add. Minus 1 plus a negative 8 is a negative 9. See that number there? Also see the 8 there. Then minus 4/3 times minus 9 would be a positive 12. See the 12 somewhere? Add 12. And then 12 times 4/3, that'd be a minus 16. Do you see 16 somewhere over here? And add these would be a minus 26. So notice I get the same answer in either case. So my my division statement, if I were to make a division statement from that, would be this. I'll put it in a different color. It would be 6x cubed minus x squared plus 0x minus 10 is equal to the divisor 3x plus 4 and the quotient, so that's 2x squared minus 3x plus 4. I'm just pulling it off right here. And then minus 26, that's my remainder, over 3x plus 4. Now notice that this answer here slightly different than the answer I'd have had up here. This one up here I would have had x plus 4/3. That's what I'd get from here. And then I'd have 6x squared, minus 9x plus 12, plus or minus my remainder of 26 over the x plus 4/3. So I'm similar, right? I'm similar. Like this one here is if I were to factor a 3 out of here, or if I were to multiply a 3 by this, I would get the same thing. Also notice there's a factor of 3 out of here. At any rate, in either case, both answers are correct. This one down here might be a little bit nicer because it doesn't have fractions there or there in it. But both answers would be correct. Okay, hope that helps with that question.